Good morning and welcome to SAT Prep. Today we're going to go over the worksheet that was homework from yesterday, which has to do with reducing radicals and using the laws of exponents to simplify problems. Some of these problems were a little tricky because you had to also remember to rationalize your denominator if there's a radical in it. And that is kind of the problem with the first one. The problem is it's the third root of the fraction a to the fourth, b to the third, over 16c to the fourth. All right, so ultimately the best first step when you have a fraction in your radical is to break it into your numerator and your denominator. So we're going to rewrite this as the third root of a to the fourth, b to the third, divided by the third root of 16c to the fourth. And that's a good place to start. Okay. Now, how do you break down a radical? Well, if you want to take the numerator first, we have a to the fourth, b to the third. A to the fourth is 4 a's, and b to the third is 3 b's. It's the third root, so we're looking for things that occur in groups of 3. So there is a group of 3 a's here, and this a has nowhere to go, and a group of 3 b's here, which takes care of all those values. So an a is pulled out, and a b is pulled out, but that one a stays under the third root. And so far, that's what we've got. This denominator of 16c to the fourth, well, we're going to break that down also. 16, if you break it down, is 8 times 2, and 8 is 4 times 2, and 4 is 2 times 2. It's actually 2 times 2 times 2 times 2. And c to the fourth is c, 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 c. So we're just breaking them down. You don't have to go right to the 2's. You could show 8 and 2, and then the 8 is 4 and 2, and then the 4 is 2 and 2. It results in 4 2's as prime factors. Still the third root, so this group of 3 2's comes out, but that 2 has nowhere to go. This group of 3 c's comes out, that c has nowhere to go. So it's 2c, and then times the third root of 2c, because that's what was left over, the 2 and the c. Now that would have been great, except there's a radical in the denominator, and we can't leave radicals in the denominator. Rationalizing is when you multiply the fraction, both numerator and denominator, by some term that will remove the root. Now, so the a, the b, all that's there. I have to get rid of the third root of 2c. Now, that means I need to multiply by something that will create a perfect cube here and there. The closest perfect cube to the number 2 is 8, because 8 is 2 to the third power. How do I get that to say 8? Well, I got to multiply it by 4. That's a c, but I need c to the third power to be able to remove the root. So I need 2 more c's, so that's c squared. So I'm going to multiply this by the third root of 4c squared, both numerator and denominator, to rationalize. What do you get? Well, the numerator, it's a, b, third root of 4c squared with an a as well, so it's 4ac squared. Down here, it's 2c, third root of 2 times 4 is 8, c times c squared is c to the third. We did this because it will actually remove it entirely, because 8c to the third is 2 times 2 times 2, so a 2 comes out, c times c times c, so a c comes out. So when the 2 comes out, it becomes a 4. When the c comes out here, it hits that c over there, it becomes c squared. In the numerator, it's still just ab to the third root of 4ac squared. That is the answer, and that answer is D. That was not easy. I understand. For what it's worth, most problems on the SAT wouldn't be quite that complicated, but we're kind of we're overtraining, and that's kind of the goal for getting ready for the SAT. Okay, the other problems weren't as hard, fortunately. All right, so the next one, it's also reducing a radical, but it's much easier. So we had 3a times the square root of 6a to the 9th plus 3 times the square root of 54a to the 11th. We're again going to be reducing the radicals first. This is addition, so we can only add if we have the same radical, just like you can only add if you have the same variable. 6a to the 9th. Now, 6 is just 3 times 2, but that doesn't reduce from a square root. But a to the 9th is 9 a's. So how many pairs of a's are there in 9? Well, there's 4 pairs because that would be 8 of them with 1 a left over. So this was 3a already. I'm pulling out 4 pairs of a to meet the one that's already there, which is 3a to the 5th. And the 6 stays under, and so does that one last a. 54a to the 11th. Well, again, 54 we could probably understand. 54 is 9 times 6. And 9 is a perfect square. It's 3 times 3. Which means that 3 will come out. The a to the 11th, again, is 11 a's. I don't want to write a 11 times, but I understand that 11 has 5 pairs in it with 1 left over. So I'm pulling out the 3 and 5 a's. So that's going to give me, just going to go over here, the 3 comes out and hits that 3 for a 9, and 5 pairs of a come out for a to the 5th, and what's left over is 6a, which is helpful because now we have the same kind of radical. We also have the same kind of variable out here, a to the 5th. So 9 and 3 is 12, a to the 5th, radical 6a, and that is our answer for number 2, which is D. Okay, number 3 is the last reducing a radical one, and I'm sure that we didn't love these all that much, but it's a skill that kind of is expected for the SAT. Let's try this one. Okay. So number 3, it was 2/3 square root 128 a to the 4th b over 8 a to the 5th. And yeah, we're going to separate this again. So this is really 2 radical 128 a to the 4th b over 3 radical 8 a to the 5th. 128 a to the 4th b. Well, 128 actually does reduce pretty easy. If you wanted to look at 128, it's 2 times 64, which is 8 times 8, which is 4 times 2 on both of them. And the 4s are 2 times 2. So I have 2, 2, 2, 2, 2, 2, 2. This is a square root. So I got a pair of 2's here, a pair of 2's there, a pair of 2's there, and a 2 left over. So what that means is there's already a 2 over here. I'm pulling out these 3 2's, and I'm going to leave that 2 under the radical, but there's also the a's and the b's. A to the 4th, well, that's 4 a's, which is 2 pairs of a's, so it's 2 pairs of a's. The 2 and the b are left over. That's the numerator right now. Obviously, I'll reduce that. The denominator has a 3, and then what else? Well, radical 8 a to the 5th. 8 is 4 times 2, and 4 is 2 times 2, so that's a 2 pulls out, and a 2 stays in. A to the 5th, well, that's certainly 2 pairs of a with an a left over, So it's 2a squared radical 2a. Okay, so 2 times 2 times 2 times 2 is 16a squared radical 2b over 3 times 2, which is 6a squared radical 2a. A squareds will cancel out. 16 over 6 reduces to 8 over 3, and it's going to be 8/3 radical 2b radical 2a. That is, where did we go? I think it's choice A. Unless I left something out. Oh, didn't leave anything out yet. Not done yet. You can't leave a radical in the denominator, as we said before. So I'm going to multiply everything by radical 2a, because that's going to get rid of the radical. So that's 8 radical 4ab over 3 times 2a, which keeps going. Again, 4 is a perfect square, comes out as 2. 16 radical ab. 3 times 2 is 6a. Again, the 16 and the 6 reduce as an 8 and a 3. 8 radical ab over 3a. Pretty sure that's the end of it. Yep, it is answer choice A. Again, I know you probably hate me for having assigned this question, and I don't blame you. So, it's a practice. It was probably more difficult than it had to be so far, but the rest of them should be easy, I hope. Lots of steps in these problems, and again, the rest of the problems I'm going to assign to you won't have that many steps, I promise. The other two are hopefully much easier for you. 4, it just says to simplify. So -4 squared x to the third x squared. Just simplify it. Please understand the negative sign, not part of the squaring, because there's no parentheses around the -4. So that's -16. X to the third times x squared, you add the powers together. -16x to the fifth is a. That was substantially faster than the other problems. Number 5 again, 5 to the 31st power equals 5 to the 3x times 5 to the 7. Please do not evaluate 5 to the 31st power. It's huge, and that's not the point here. The point is, when you have the product of the same base, you add the powers together, and it gives you that base to that power. So all you're supposed to do here is say 3x, not 36, 3x plus 7 equals 31. That's what this is supposed to get you. Subtract 7 from both sides, and 3x equals 24. Divide by 3, and x equals 8. That's the way to answer this question. That's answer choice C. That was the assignment. Okay, what I want you to do now is the worksheet that's attached to the announcement. It's much simpler. It's mostly just going to be a review of the rules of exponents, which I talked about yesterday and gave you a full review of. There's, I don't think, any reducing radicals, and the questions themselves are fairly straightforward. I'd say they're pretty simple. Please have that done as soon as possible, but no later than Monday morning at 7 a.m. Have a great weekend. Let me know if there's any questions or problems. Log into the Meet if you would like to, and that is all for today. Have a great weekend.